Fine? Okay.
Eu também.
So I'm Bren. I work for Cere Network. We do AI and data automation on top of Deepin. And before I start this presentation, I want you to take a moment to imagine a world where you have personal AI agents working for you all the time. I'm not talking about going to ChatGPT, entering something in the prompt, and then have them do something for you, hopefully right. I'm talking more in the sense of when you go to a very nice hotel, and there is somebody waiting at the door, opening the door, taking your luggage, taking it up. You don't have to ask. And that's what AI agents should do for us. They should just be there 24/7, doing what we know we want to be done. So in this presentation, I'm going to explain how I think Deepin, blockchain, and edge computing can get us there. So first things first, what is edge computing? It's a nice Wikipedia explanation. Edge computing is a distributed computing model that brings computation and data storage closer to the sources of data. Basically, it means we're going to take whatever resources that we need to run the application that we want, and we're going to put it right next to the user to reduce latency and so forth. So what do we have now? I think everybody here in the room probably uses a cloud solution, has its data on a cloud. You can also imagine that most of the people here, they don't have an AWS data center right next door, which means that the data has to go pretty far, which introduces latency. And if you do that with millions and millions of people and everybody is sending data across the world, then you're eating up the available bandwidth. You can also imagine if we store all the important information in one place, controlled by one centralized entity, there are inherently some security and privacy risks. And when we take a look at edge compute, if I put an edge node in your street and you interact with an application and it only has to go a few hundred meters, you can imagine that is faster. You're taking up less bandwidth, lower latency, and also it reduces some privacy and security risks because you're not sending the data across the world. Now, if you've been in the tech space for some time, you're probably saying, well, edge compute, that's nothing new. And you're right. The term was coined in the late 90s, so that's a quarter century ago. So it makes you wonder then why is this not the standard? Just like any model, there are some challenges also with this one. One is the infrastructure cost. You can imagine if you want to put an edge node in every street, and you have to do that as a company, you got to buy everything, you got to install it, you got to maintain it. That's a huge upfront cost. Second, the interests aren't aligned. In the past decade and more, big companies have spent a lot of money invested in the cloud infrastructure, and they need a return on investment. It's that simple. You're not just going to switch because something else nice comes along. In general, also, distributed networks are a bit more complex than when you manage everything as a central entity. And last but not least, not every application needs it. I mean, if we're surfing, we're happy. We get a 100 ms delay. Most applications, it's fine. So it's a limited amount of use cases that we've had in the past that can really benefit from edge compute. Of course, I wouldn't be here if I don't think that's going to change. And I think that's definitely going to change, driven by AI. Not only that, we also see an evolution when it comes to data and privacy. And data sovereignty is getting more important. The privacy of the data is getting more important. And on top of that, as the examples that I gave, if we want that next generation of AR and VR applications, then you need real-time performance. If you want that next level of hyper-personalization, you need less latency. And I think, and we slightly touched on that, if we do it right, we can have a more efficient use of resources. And if you know that AI is exploding, it's really growing exponentially, it also means that the need for resources is growing exponentially. So managing them more efficiently is important. And the last one, this might seem contradictory to what I said before, is economical benefits. I know I said the infrastructure is going to cost a lot of money, but we'll touch on that in a second, how I think we can solve that with the technology that we have now. For that, we're going to look at centralized versus decentralized. So what we're doing now, you're going shopping on Amazon, you fill in your address, your email, telephone number, and so forth. Fine, goes into their database, run by their infrastructure. Then you go to Corte Inglés or wherever you want to shop, put in the same information again in their database, their infrastructure, order something on Glovo, same thing. You get the point. You got duplicate data, redundant infrastructure, add those together, and you have higher costs. I think if you use deep-in infrastructure, and if you use it right, it's not because you use deep-in that automatically all the problems are solved. But if we use it right, I think we can motivate people to share the infrastructure that we already have, which is more economically efficient. We can make it easy for resources to come into the network, go out of the network. Imagine AWS. They want a new data center, they got to go somewhere, rent it, get those servers, and so forth. It's going to take a long time. Or they have to do a contract with a local contractor, a local supplier. Again, takes a long time. Put a deep-in network, I join, I leave, done. And then I want to touch on user-centric data. And that's a very interesting one, I think. I think with the right deep-in infrastructure, you can design an infrastructure that allows for this, and that means that all the data is with you as a user. It sounds very basic, but I think it opens up a lot of innovation. Because right now, if you want to develop an application, I got to think, where am I going to get that information? Yeah, I want information on where you're going. Maybe I can contact Uber. Hopefully, they have an API. I want your shopping information. Maybe Amazon wants to give it to me so I can make a very nice application. And even if the APIs are available, like with Twitter, you have to pay every time you interact with it. So maybe it's too costly. But if we have user-centric data, I just have to ask you, because I know you have all this information, and I just have to ask you. I don't have to wonder where to get it or how much it's going to cost me. I know I can just ask you. And if you're wondering if that is realistic, well, I'm going to take the use case of Helium. Helium creates wireless networks using deep-in infrastructure. So as we can see, they have 1 million devices, so all the purple things that are devices in Europe, but they have it worldwide. And the interesting thing is, they didn't install these devices. They didn't buy these devices. They don't manage these devices. It is you, me, normal people that said, OK, I'm going to pay a few $100 bucks. Going to buy that thing, going to install it at home, and going to run it. And we have 1 million of those. It's not insane, but it's a nice number. It's nice performance. Compare that to a telecom company. If they want to set something up here, they're coming to Lisbon. They're going to say, that's a nice building. I think that's going to give me good reach. Knock on the door, say, I'm going to pay you every year to put up a big antenna that I'm going to buy, that my employees are going to install and maintain. It's a huge cost. And yes, Helium is paying tokens as well, but these tokens represent future value, while the telecom company has to pay real dollars right now, instantly upfront. That's a big difference. So putting these two things together, I think a very important one is transparency. If you use blockchain, inherently there is more transparency because you put it on a blockchain. It's that simple. If you look at Google or Amazon, you don't know what's going on behind those doors. Even if you have a search warrant, maybe you get something, but that's it. And I gave the example as well, if you're Amazon, you want to set up a new data center. It's difficult. You got to ask corporate. It moves down. You got to go to location and so forth, do a bunch of meetings. Even if you use a local supplier, you got to do a meeting, take this big contract of 500 pages, hope he signs. Well, with a deep-in network, it's all automated. You can install the node, run it, join, great. And that brings us to the second one. What if somebody doesn't behave? Well, even that is in smart contracts. So if you don't behave, you get slashed. If you still don't behave, you're out. If the supplier doesn't behave, Amazon says, do something about it. And if you don't, they're going to send a lawyer. And that lawyer is going to go to court. It's going to cost a bunch of money. And the whole legal system, blah, blah, blah. It's not that efficient. So a good, well-designed deep-in system is more flexible. And if you do all of these things right, you have less overhead, higher efficiency of the resources, so that should push down the price. So hopefully by now, I convinced you that deep-in can be an interesting solution. That brings us to the next part of the story, which is user-centric data. So how are we going to get user-centric data? And as I said, there are nice solutions for that. And of course, we've built one of those solutions, which is Cere network. So in this example, we got Alice, and Alice has a data wallet. And we see we got some purchase information from Amazon, we got some travel information, health information, and so forth. And then we have a developer is going to make an AI agent and says, well, with that information, that can be interesting. Because I see, based on the health information from the Garmin, Alice has been a bit stressed for several days. And I know she likes to go on vacations, maybe to Lisbon. And I know in her calendar, in 2 weeks, she has time. And I know from her bank statements, I can plan a trip that will make her relax within her budget. We can make an AI agent like that and just ask Alice for permission and let it run. And in an extreme example, let the agent book if you really trust him. So if you put these two things together, we got decentralized data, and we got decentralized infrastructure, and we want to get to that edge compute, well, then we get decentralized edge clusters, and that's exactly what we built with Cere Network. We allow anyone here in the room to launch their own cluster and invite people to join with their resources. If, for example, you think well, it's a good idea to have a decentralized cluster that has completely GDPR compliant, you can say, I'm only going to accept people that have enterprise-grade resources and that are GDPR certified, whatever. Or if you say, well, maybe I'm going to make a cool AR, VR application specifically for Lisbon, has to be lightning fast, well, then you spin up a cluster specifically for that, and then you invite developers to use yours and join that piece of infrastructure. And if you're wondering, like, how far in the future is this? Well, we actually built a prototype. And in this prototype, we took a use case example of a security agent. So imagine a big factory. You have that guy sitting behind the screen, keeping an eye on everything. In this case, they have drones flying over, so they're pretty advanced. So he's looking at all the drone footage and seeing if there's somebody walking there that shouldn't be walking there. 8 hours a day, next one comes, hopefully it gives him an update, next one comes. So we decided to automate this. So the drone gives the video footage to the AI agents, and they're going to process it, and if they see something that is wrong, which is probably more efficient than the guy sitting behind the screen, he gets an alert. And to make it more visual, we got a use case example. Okay, cool. So here we see drone footage, and they're not just keeping an eye on the site. It also sees one of the agents says, hey, this is a train cart. Cool. Talks to the other agents and says, hey, do you see a label on here somewhere? He says, yes, got a label. And then gives it to the other guy and says, do you know what the label says? So the other one reads it. And then based on that information, we're saying we got these tracks, and on these tracks, we got these carts, and we're doing inventory management. So rather than somebody looking at the whole visual feed, you can just look at this, which is obviously more clear. So it's a lot easier to manage. So that's what we're doing here. So we're combining very simple agents, and we're using our agent orchestration tool to work on that raw data to get this. And then, for example, what we see here is basically Google Maps, and we use that same information just for another representation, which again can be useful. So how does it work? And maybe because you've been seeing a lot of presentations about blockchain solutions. So we use the blockchain specifically to manage the hardware itself. So the data is mostly stored off-chain, but of course encrypted and completely safe and private. So in this case, the drone flies over, collects the data in a data bucket that he encrypts. He then gives access to the AI agents. Again, they have access, so they're allowed to decrypt it. They do what they have to do, just what we talked about. Send the result back, goes to HQ, and then they can give feedback to further improve the work that the AI agents have done to create this positive feedback loop and increase performance even further. So I hope this gives you a good idea of what is possible. It's not exactly the example that I gave in the beginning, but hopefully you will see that we're getting definitely closer to that reality than you might think. If you are a developer or just somebody who just enjoys tech, please scan the QR code. That will take you to our developer console. I will move so everybody can scan. It's very easy to use. Just sign up with your email, You will need some data credits, so you can ping me on LinkedIn, on Telegram, whatever. I'll give you a few gigabytes to play with. Even if you just want to upload a silly video, you can. So be sure to check that out. Of course, we have the official website, Cere Network. You can follow us on Twitter. And again, if you have specific questions, I'll be around here for another 30 minutes. Or you want to get connected, that's my LinkedIn, or you can add me on Telegram. So yeah, thank you all for listening.